Okay, I'm going to try and do a couple of these problems here real quick. 6.1. I think I finished up 25, so I was on number 26. So number 26, integral e to the s sine t minus s. E to the s sine t minus s ds. So the variable in the problem here is s, and we're going to treat t as if it's a constant. I'm noticing that I've got a product here. I've got, if I choose this to be u, I know that derivative's it's just going to stay itself. If I choose this to be u, I know it's going to switch back and forth between sine and cosine. But this was the one that we had seen where we get that special thing to happen where we get this to appear again somewhere, and then we move it to the other side. So let's go ahead and start. I'm going to let u be equal to e to the s. Du is e to the s ds. V is sine t minus s ds. And integrating up, we get, dv. V is equal to negative, hold on. You have to be a little careful here because we have a negative 1 in front of the s. So remember, we're going to have to scale by the number in front of s. So we're going to have to scale by negative 1, or 1 over negative 1. But the antiderivative of sine is negative cosine, so the negative and the negative will cancel and become positive. I shouldn't say cancel, but so it'll be this. So take derivative real quick. Derivative cosine of something is negative sine of it, right? Act like there's a negative out here. Then derivative of the inside, derivative of t is 0. Derivative of negative s is negative 1. That negative 1 comes out over here, and that's why you have a positive. So that's correct. So this equals, right down here, this here equals ultraviolet, e to the s, cosine t minus s, minus integral voodoo, here, I'll just rearrange it, e to the s, cosine t minus s ds. And now I'm going to do integration by parts again on this piece. So I'm going to set up a new table. And I'm going to let u be equal to e to the s again. And du will be e to the s ds. dv will be the cosine of t minus s ds. And then v this time will be negative sine of t minus s, because the antiderivative of cosine is sine, but then we have to scale by the number in front of s, which is negative 1, so we had to put a 1 over negative 1 here, which is the same as negative 1. All right, so what's here is going to be a new ultraviolet minus voodoo. So we have the original ultraviolet right here, minus, in brackets, this new ultraviolet, which is this times this. So negative e to the s sine t minus s minus integral voodoo, which is here and here. And notice I have a negative sign here, so I'm going to make this a plus. And then we're going to have e to the s sine t minus s ds. Let me make sure that it's coming out. Close it off. And now what I'll do is I see that this integral is the one I originally wanted. So all of that is equal to this. Let me distribute the negative through. When I do that, I will get this, e to the s cosine t minus s, minus minus is plus, e to the s sine t minus s, and then minus and plus is going to be minus this integral right here, e to the s, I'm running out of room, sine t minus s ds. And now I'm going to add this integral to both sides because it's the same integral. So I add it to both sides. when I add this integral, whatever, goes away. When I add that integral over here, I get two of them, right? So I'm going to put that down here. I'm going to have two of these integrals is equal to these two right here. E to the s cosine t minus s plus e to the s sine t minus s. And then I just divide both sides by 2. So the 2 goes away here. I'll just put a 1/2 in front of this. I'll squeeze a 1/2 back in here. And then remember, we have a constant of integration. Okay, so that's 26. 27, I believe I did 27 in class. But on 27, they're telling you to make a substitution first. Oh no, I didn't do this one. So it says, first make a substitution, then use integration by parts. So integral cosine square root x dx. So the substitution I'm going to make is, it doesn't look like I should make this, I'm doing basic substitution. Doesn't look like I should make this substitution because I don't see the derivative of this anywhere. But let's see what happens. I can say du is 1 over 2 root x dx. And remember, in class I also said that you could square both sides instead, and then take the derivative here implicitly. So the derivative of u squared is 2u du equals derivative of x, which is just dx. So you could use this instead of doing this. See, on this side, what you have to do is you have to get your dx by itself to match up here. So you have to multiply both sides by 2 root x, and that would give you this. And then you have to realize that u is the square root of x. So this will become 2u du. And that's what we have right here. So this is a little cleaner. So now I'm going to rewrite the problem. I have cosine, square root of x is u, and then dx is 2u du. So I'm going to put the 2 out here. I think I'll put the u in front of the cosine. 2u, so 2u du. And now for this one, I notice that if I use integration by parts, I can choose this as my u, even though I can't use u because I already used it. And I know that when I transfer the derivative of this is going to be 1, and I can integrate this pretty easily. So now integration by parts, I'll do it here. I can't use u, so I'm going to use w. I'll still use dv here. dv has to be the cosine u du. W is u. dw is du. v is sine u. So integrating up. So this integral becomes 2, don't forget the 2 on the outside, then ultraviolet minus voodoo. Ultraviolet minus integral voodoo, integral sine u du. And I should be able to do that. Antiderivative sine, I can figure that out. So now we have 2, I'm going to distribute the 2 through, 2u sine u. And then the antiderivative of sine of u is negative cosine u, so the negative is going to become a plus here, and the 2 is going to come through. So 2 cosine u plus a constant of integration. And finally, let's replace all our u's with what u was in the problem, which was x. So 2 root x sine root x plus 2 cosine root x plus c. So that's 27. I have probably enough time for 1 or 2 more. 28. T cubed e to the negative t squared. All right, so on this one, again, it's telling us to make a substitution first. This is almost a basic substitution because the derivative of t cubed is 3t squared, and I have a t squared up here, but the problem is we can never have the derivative. In basic substitution, we can never have the derivative appearing somewhere else, like hidden or trapped inside of another function. So we can't do it that way. But we know that the derivative of this is going to be negative 2t, and I actually do have a single factor of t here. I have 3 factors, but there is actually 1 factor in there too also. So let's try that. Basic substitution, let's let negative t squared be u. du would be negative 2t dt. And so let me rewrite this so we can see that we actually had that. That's t squared e to the negative t squared times t dt. So I just peeled one of the t's off over here, and so that I could get this t dt to match up. And so that means I'm going to scale this. Negative 1/2 du will be equal to t dt. So I'm going to replace t dt with this. And I'm going to replace, let's see, negative t squared with u. And then the question is, what do I replace t squared with? We'll just take this equation real quick, multiply both sides by negative 1. We know t squared is just negative u. So this integral becomes t squared, which is negative u, times e to the, that's just u, and then times t dt, which is negative 1/2 du. And I can pull the negative 1/2 out. The negative here becomes plus. So we have 1/2 u e to the u du. And now for this, notice integration by parts. If I choose this to be my u, right, the derivative of that will be 1, and then integrating that will be easy. So we should be able to set up a table here for integration by parts. But the basic substitution got us to this. So here we go. Can't use u, so I'm going to use w again. I'm going to let w be the u. That means dv is going to be the e to the u du. That means v is e to the u. dw is du. So this integral I'm going to rewrite up here. This integral becomes, let's see, 1/2, then integration by parts, ultraviolet, u e to the u, minus integral here, e to the u du. Antiderivative of e to the u is itself. Let's distribute the 1/2 through. So 1/2 u e to the u minus 1/2 e to the u, again because the antiderivative of this is itself, plus c. And now let's just replace all of our u's with what u was. And I already erased it, but it was negative t squared. So this is going to be negative t squared. I'll pull it out the negative. Negative 1/2 t squared e to the negative t squared. And then minus 1/2 e to the negative t squared plus a constant. So that should be it right there. All right. See if I can get one more in. I'm sorry, I know it seems like I'm rushing, but I am, because I'm in a hurry to get to class here. 29. Integral, we have theta cubed cosine theta squared d theta. We're supposed to make a basic substitution first. So I'm going to make a basic substitution, noticing again that the theta squared, the derivative of that is just 2 theta. I have 3 factors of theta here. So I already know ahead of time I'm probably going to need to peel one of those factors of theta off. Here it is right there. But let's make our substitution. U is going to be theta squared. du is 2 theta d theta, which means 1/2 du is theta d theta. So that theta d theta right here is going to be 1/2 du. So now this integral becomes theta squared, which is u, cosine theta squared, but that's u, times 1/2 du, so I'm putting du back here, 1/2 out here. And now again, we're kind of getting into repetitious mode here. I can do integration by parts on this. If I differentiate that, it goes to 1. If I integrate that, it becomes sine. So our table, using w to be u, dv is cosine u du, dw is du, v is sine u. And now this becomes 1/2 ultraviolet u sine u minus integral of sine u du. Antiderivative of sine is negative cosine, so that's going to become a plus when I integrate, and I'll distribute through, so I'll have 1/2 u sine u. Again, that becomes a plus because the antiderivative of this is negative cosine. I have a 1/2 cosine u plus c. Replace all of your u's with theta squared, and we're done. So we should get a final answer of 1/2 theta squared sine theta squared plus 1/2 cosine theta squared plus c. One more? Yeah, let me see if I can get 30. If I get 30, I'll be happy. 30. So for 30, we're integrating, oh, I did this in class. I did this in my class lecture. So I'm not sure I should even work through this. Maybe I'll just get it set up. U is equal to root x, basic substitution. I'm going to square both sides. I'm going to differentiate both sides. We just did this just a second ago. And then I'm going to notice I can replace dx with this. I can replace square root of x with that. So this integral becomes integral e to the u. But then dx is 2u du. So here's 2, here's u, here's du. And we've done that already. So you do another integration by parts table here and break that down the rest of the way. Okay, I think that's it. That's all I'm going to do for this section. The other problems in this section that involve reduction formulas, watch my lecture video. Those are more involved. I would probably only give that as a bonus question to try and come up with a reduction formula. So I won't do a video on it. All right, I hope that all helps for this section. Have a good one.